Okay, ma. Start.
Good morning, one and all. It's my great pleasure to welcome our guest, Professor Dr. S. Venkatesa Prabhu, Center for Food Nanotechnology, Karpagam Academy of Higher Education, Coimbatore. He has completed his PhD in Anna University. He is having 22 years of teaching experience in engineering. His professional interests focus on environmental, biochemical, food process engineering, and enzyme technology. He has completed his research projects, which were funded by Ethiopian government. He is a life member of Indian Society of Technical Education, Indian Institute of Mineral Engineers, Material Research Society of India. He was honored with Young Scientist Fellowship Award from Tamil Nadu State Council for Science and Technology. Sir, please.
Porkodi unmute Venkat sir. Hello, Porkodi. Sir, good morning.
வந்து துரோகம் பண்ண மாட்டாயா ஏறு ஏறு இது மாதிரி வெளில கிளம்புற மாதிரி ஐடியா இருக்குன்னு சொன்ன இல்லையே.
Participant may kindly switch off their video and audio, please. Dr. Govindaswamy, please switch off your video.
Sir, your voice is not audible.
ஹலோ சார், ஆடிபிளா இல்லைன்னு நினைக்கிறேன் சார்.
Sir, audible, sir.
Sir, is it audible now?
Yes, sir. Yes, sir.
So, shall I start? Is it audible now?
Yes, sir. Yes, sir.
Okay, sir. Okay. Thank you. Okay, so thank you so much. So, sorry for this disturbance. Actually, I would like to start with some basics food biotechnology and food process engineering, food packaging material. So, first of all, already I have told about this PPT. Special thanks to Varna Engineering College Management and Dr. Selva Kumar, especially for inviting me to give this talk. I would like to plan to share my thoughts and also discussing about our research work related to unusual in research. What we have, what you are doing in India and in Tamil Nadu, food related and everything. Because previously I was working last past 6 years in Ethiopia. So we have obtained some funded projects from Ethiopia government, and also we have worked some biotechnology food related work in in Ethiopia, especially Addis Ababa Science and Technology University. So I was working for 6 years. So I would like to just discuss about what we have done in Ethiopia in related to food activities. And also, basically, I'm a chemical engineer, so we have worked and developing some novel products and edible food packaging materials, and also isolation of natural products, such kind of things we have done. So maybe this will be giving some new idea and understandings what we have done with respect to very unique regional related food process engineering and all those things. Just 2 to 3 months before only, I have just returned back to India and joined in food process engineering in Karpagam College of Engineering. So that this maybe will give a very interesting idea and theme to you. What people are working, researchers with related to food process engineering in very specific to Ethiopia. That's why. So even though, so I would like to start with some food biotechnology, food process engineering in basics of food process engineering under the topics green biotechnology. So this one. So, food biotechnology is a single term we can say is an umbrella, is covering the vast variety of process using living microorganisms. So normally, so there is no need of any introduction. So such a plant, animal, and microbes we are exploiting to develop a new product. Now we are going to very emerging related area food process, means food products. And also the newer form of food biotechnology, so that offer a faster and more precise means developing food products. The people are showing interest on this, but it's not very recently emerging techniques. Actually, the food biotechnology is not new. Even thousands of years, people are being discovering. Fruit juices, fermented wine, and all those things past so hundreds of years. The people are working on that. The people are doing without knowing biotechnology behind that one also. So that the beer made through the fermentation of malt. So without any special introduction or discussion, we know about the food biotechnology behind that. Even 1860s itself, uh, the scientists, mental genetic principles that became very specifically to work under this food biotechnology. So, in this context, I would like to just start about people may think about the term biofortification in terms of food biotechnology and plant breeding and also developing novel food products. The biofortification will give the novel idea, new idea, because the biofortification is the process of increasing density, vitamins, minerals in crop itself through plant breeding. These and all some novel area, newer area, emerging area, but it's not a new. May the people attending here the faculty development program. So the biotechnology, plant biotechnology people think about it. So how to develop even after harvesting, before harvesting, how we develop biofortification and all those things. See, uh, some justification regarding this biofortification, micronutrients and also some deficiencies is giving trigger to think about biofortifications. So that the biofortification, however, two key cooperative advantages: the long-term cost-effective and also the ability to ability to reach rural populations. So that is the main key advantages for thinking about biofortification. So when talking about biofortification in around the globe, around the world, these are some examples already the people have targeted and achieved based on some micronutrients. So iron and also the vitamin and also the zinc. These are all they undertaken research activities and achieved some this kind of targeted. So we have also achieved the zinc wheat and also even biotechnology zinc fortified wheat from the Pakistan. So these are all. So iron millet from India is also achieved recently. It's having some good potential outputs. So after that, here phytochemical constituents, advanced extraction technologies, and techno-functional properties of selected plants for especially meat-related product. Not only meat-related products, the plant extract and essential oils can be used for any kind of fortification. So while doing processing and developing a product. So in that point of view, Mediterranean plants normally, so the Mediterranean plants, மத்திய தரைக்கடல் பகுதின்னு சொல்லுவாங்க. So the people who are easily harvest such kind of plants without knowing the potential of phytonutrients. Even in Ethiopia, I will show some examples. So the plant extract, not only extract, even essential oils also can be effectively exploited, used in terms of natural antimicrobials, antioxidant activities, for especially for shelf life activities and also developing nutritional activities and meat products. So they are increasingly becoming improved to improve as additives meat industry and extend shelf life and increasing acceptability also. Normally, the high phenolic content what allows to color stability and decreasing of flavors also. So these essential oil and plant extracts are getting emerging things now. The people are working in especially Ethiopia. So some Mediterranean plants, normally we are calling Mediterranean plants, and also very commonly available each and every places in roadsides also. Rosemary here also available in Tamil Nadu in India. So garlic, lavender, leek, olive leaf, onion, and these are all some examples. So this is the view, the picture. So it's taken from roadsides of Ethiopia, having very high phytochemicals and also high level of plant extracts. They are now examining to use in food process engineering. So Sachuraja, Montana, and also sage, and this is known as leek and also lavender. So these are all some examples. People Ethiopia normally they are using in food also, but the people can think about to extract plant extract or essential oil on this thing also can be what to find the new products and new development of food process engineering also. So in this context, extraction technology, I would like to just discuss as a chemical engineer. I don't want to give up on extraction technologies, and also extraction is very, very important for food process engineering. So, the plant extraction is a separation process only. So the extract the desired soluble plant and metabolites, phytochemicals in insoluble plant materials, we can make into soluble. The process involves the separation of bioactive and active components, the plant using specific solvent system. This is the theme behind extraction. But however, now I would like to just say about novel new extraction technologies, not a traditional one. This is the traditional one: solid liquid extraction, liquid liquid extraction, and also now in this faculty development program, these things are very important to know about the emerging extraction techniques. So these are all alternative technologies because of some particular points to think about why. Low extraction yields normally in traditional extraction process, and also it takes long extraction, high solvent requirement, and high energy consumption also, and some chemicals. It can be giving potential health hazards to trigger the research people to work under emerging extraction techniques. So what are they? So this the diagram have now recently people emerging extraction technologies, HSPE, ASP, AF, MAE. So what are all they? So I'll show you. So the reason thing, this one AAC and enzyme assisted extraction, then high voltage electrical discharge extraction, then infrared assisted extraction, microwave assisted extraction, pulsed electric field extraction. So here, some advantages and drawbacks also will be there, and extraction conditions I have just summarized in this PPT. In future, I can share this PPT. You people, you can go through it and understand what kind of extraction techniques can be used for specific materials to targeting specific phytochemicals. So, however, I would like to just give you some idea on this emerging extraction techniques. Even supercritical fluid extraction, and nowadays the people are working ultrasonic assisted extraction. So now essential oils. So here I would like to just discuss about essential oil that also having some emerging food processing techniques that can be used for your developing new products and also uh, food related products. Essential oil referred as it's an oil, and it can be extracted from different parts of the plant: leaves, seeds, woods, bark, roots, flowers, and rhizomes also. So more than so far 300 essential, 300 out of 3000 of them are utilized for some commercial purpose also. So based on this commercial purpose, essential oil, uh, other than this, we can use as a food related applications. So towards essential oil applications, the mechanism is very important how it works. Essential oil are complex mixtures containing over 300 different compounds. So it is very important that how the essential oil can be applicable for food related product developments. Nowadays, I didn't include here the topic nano emulsion. So normally essential oil is applicable for developing food products for different areas, even edible films and also food packaging material also. So based on the mechanism, the essential oil can be developed in terms of emulsion, that is nano emulsions. So that can have very high potential value added properties for developing edible films or films, biodegradable films, antimicrobial films, antioxidant films for especially food packaging material and also different applicability. So the after essential oil extractions, the people can think about nano emulsion preparation and application towards that area. So after that, this is the basic two important constituents, the turbinoids and phenyl propanoids. So the phenolic compounds basically is acting behind the essential oil activities with respect to antimicrobial and antioxidant activities. So these are all major advantages of the essential oils. So as you see, antioxidant, anti-inflammatory, anti-cancer, anti-diabetic, antimicrobial, and this is not only this. I have given very condensed advantages here. So the essential oil are very important. You can think about how developing essential oil, extracting high yield of essential oil from different peculiar herbs, so that the people can think towards essential oil. And also processing of essential oil, as I told you, you can think about the nano emulsion in terms of using essential oil. So here, this topic, it's very interesting. Normally, not only extraction process, extraction technology, how the solvent are going to impact extracting bioactive compound. So the smart advanced solvent in terms of bioactive compound recovery basically is highly impacted by the solvent that can be used. So as a chemical engineer, as a food process engineer can think about the solvent, how it can be used. So now recently the deep eutectic solvent, DES, and also natural de-eutectic solvent. So chemical based de-eutectic solvent and natural based de-eutectic solvents are emerging now by use of bioactive compound high yield recovery uh, that can be done by this kind of new emerging solvent use. So because of the advanced smart solvents have some advantages. It is not having toxicity because traditional technological methodology having high toxicity, basically chemicals we are using, and high volatility and non-renewability. So in that point of view, to overcome this, so these are all some uh, reasons people thinking to work under such kind of solvents. uh, Excellent biocompatibility and no low toxicity is triggered for working under deep eutectic solvents. And also, so stabilizing capacity and extracted solute possibility to form of hydrogen bond between a solute and deep eutectic solvent, so that no harmful effect, the property can be highly protected by using of deep eutectic solvents. So people can think about the deep eutectic solvent. These are all some examples given in 2003 itself. Researchers have started work under choline chloride, and also some examples are given here. So these are all some excellent features of think about the novel solvent deep eutectic solvents. So their preparation is very simple and cheap and are considered, and the tailor-made solvents and process fine-tuned phytochemical features and low toxicity and also the biodegradability. All those things are major advantages of using this one. These are all some types for type 1, type 2, type 3, and type 4. So the people are now concentrating to extract the biological compound from any type of biological plant material or anything. So this is the some combinations I have given. Basically, deep eutectic solvent can be prepared by using such kind of things. So HDB. HDB is a hydrogen bond donor. So you can go through it if you want to know, and you can have some idea regarding that the particular combination to make about type 1, type 2, type 3. Then you can select the biological compound and also type, then prepare the deep eutectic solvent. You can make to optimization process further extraction with respect to solvents. So I have summarized here in this table about people what they have worked previously, and this is the compounds the people are working. Even now also the orange peel and grape peel and some bioactive compounds and what kind of extraction methodology they have worked. And I have just given some summary in this table. Now. Until now, I have just discussed about the work regarding to food process engineering, extraction methodology, and essential oil and mechanism, all those things. Even though these are all very common, people have known. I know, suppose. Maybe I would like to start with some basics with respect to new things towards the solvent extraction technology and biofortification like that, so that now I do like to discuss with you. People have not known frequently what we have done, and also the things what we had a good experience in Addis Ababa Science and Technology University, so that it may have some interesting things to you. Maybe next half an hour or 20 minutes, I would like to discuss with you. So this is the TIF. It's a small grain. It's only available in Ethiopia. Other than Ethiopia, nobody, no country are not having this grain. It's very peculiar to Ethiopia. So this is the staple food. So in this staple food, previously people are just it's a protectable out of Ethiopia. It cannot be taken by anybody. Only flour can be taken. So after we went there and we try to work under the TIF extraction and some compounds and related activities. This is the TIF field actually. Uh, this is the normal food. People they are eating 3 times per day. It's known as in local name Hamari. It's called as injera. It's like a dosa. It's normally prepared by a flour developed from this grain. It's known as step. And it normally it has been fermented 3 to 4 days. Sometimes the people the flour, the dough can be fermented more than 7 days. It's completely fermentation has been taken. After that, the special method is used to prepare such kind of dosa is known as injera. It's completely gluten free. This only the people are eating normally. It's a traditional food for Ethiopia. But now the novel thing, the new thing is how the bioprocess engineering or bioproducts, food product can be developed from this injera. It's a pure injera without any additional value added product, only fifth grain ingredients is having here. But now, after recently the last decade, the food process engineering and food process technologists are work with respect to different fermentation processes and different combinations of tips. So we have developed different kind of food products based on injera. More than 7, 8 different injera products were combinations of different ingredients like sorghum, barley, wheat, rice, and also different fermented bacteria, because the fermenting bacteria is also producing. Normally people are fermenting 3 to 4 days, but we have used very specific bacteria to ferment that particular to prepare that injera. How the vitamins and everything is going to be increased or decreased or impacted, we have developed 7 different products, and it has been patented in Ethiopia past for 5 years. And after that, it's a gluten free. It's a tips injera has exploited by the microbe. It has having some peculiar microorganism. More than even within 8 to 6 days, the different microorganisms have developed. While we were working under to extract some peculiar microorganism in injera, because injera is not available anywhere. It's gluten free, and also some peculiar ingredients are available. We try to isolate what kind of microbes are there. But here, more than 7, 8 different microorganisms like fungi we have isolated here. Interestingly, one particular microbe was isolated from the injera, and it has been identified as this one, Aspergillus flavus. It have it has identified that ability to produce high alkaline proteins. So under project, we isolated this particular microorganism and identified this is Aspergillus species, and more than 80 to 90% of gene sequence is matched with Aspergillus species. Then we identified that the protease producing microorganism is very easily developed from the injera, and it identified that the microorganism, and after that optimization has been done, basically different enzyme and kinetic aspects, and it's published here. And also another important things, as I told you, this this step was having different things. The grain straw is having high biosilica content. We concentrated on extracting biosilica from the straw after harvesting the teff. It's identified that more than wheat and more than rice straw, it's having high yield of biosilica gel. So then we identified that different optimization process can be applied, and how the silica, biosilica is extracted. So in this food process engineering related biosilica gel, biosilica is highly effective to prepare edible films or film preparations and such kind of reinforced biodegradable film preparation. So that I do like to just give you the silica gel prepared, and also it's published here. And another important thing is some tubers. It's still unexplored. Even this kind of tubers are identified in regional, very peculiar area in particular regions. We cannot see normally in Ethiopia in the city side also. Some particular traditional food is having is unexplored and having high nutritional value with respect to starch and also with respect to additional nutritional products. We identified this Coccinia abyssinia. Normally, it's called as bagana. It's a tuber. This tuber is not available everywhere in Ethiopia. Even in particular, people religious using this one as a staple food. So we have identified that to extract some starch and improving yield this starch from this tuber, and we identified that the people are having such kind of staple food and how they are utilizing that starch. But now after that, we extracted starch from the particular tubers, and we worked under some modeling and preparation of edible film. Then finally, we published here with respect to starch-based edible film, especially the starch extracted from Abyssinia, that is Coccinia Abyssinia. Abyssinica means it's basically it's available in Ethiopia. It's not meaning only in Ethiopia, but maybe it can be emerged in future anywhere. That I just discussing, just telling about identification of any new novel unexplored underutilized product can be developed here like this also. That's why. So the next thing is this is not seen everywhere in world, and also anywhere it's not available. It is known as NSET. Normally it's available in Ethiopia, nowhere in anybody anywhere in the world. It's known as false banana. Locally we called NSET. This is looks like banana tree, but it's not a banana tree. This is also a staple food for Ethiopia in particular region, not for in all regions. Especially southern part, the people are utilizing this one as a staple food. Staple food means they are taking the food developed from this tree as 3 times per day, morning, afternoon, and night. How? See, normally the people are extracting the starch, the rhizosome or the root starch. It having high level of starch content like this. It's a tree. It's a center part of the tree. It's having high level of starch comprised product, and also rhizosome also. So the people are scrapping and they are fermenting, and after fermenting it has been utilized as a staple food like this. Actually, this is the fiber. It's taken from the outer part of insect. That also is going to be used as a food developing product. In this region, people are scrapping the powders of insects, and they are putting like this 3 to 4 days to ferment. So after fermentation, such a starch product, they are making as a bread like this. Is commonly called as pocho. This is the normal activity of people, what they are doing in particular religions in Ethiopia. So we have taken as a project to develop a new product, and we have identified that this particular starch extract is having more than 90 to 95% of starch. So the starch is going to be used as additional value added product. So the project we have done to develop extraction of starch, and this particular starch can be used as from additional value added like this. So we have undergone to work under some project. In the project, we identified that the modification of starch, especially extracted from the insect, the starch is modified by alcoholic alkaline treatment by using freeze drying. We developing the modified starch having high appreciable properties because the starch is developed from very peculiar from Ethiopia, and also different product is going at present under in research. The modification of starch based on your target product, maybe it can be used for edible film or a tablet, and also even applications of functional food as a different food, so that the optimization we have done here with respect to feed drying, and the property is very improved. We have identified this, and also the same insect starch is subject to approval for food packaging material. It's comparatively very nice with respect to normal starch extracted from topica, and also the starch extracted from wheat, rice. So there is no that much different, and also having some value added product, and it's very peculiar. Uh, uh, some it has published here also. Another one is things, as I told you, the cellulose and nanocellulose are very important things, can be used for biodegradable film reinforcement and also food packaging materials. So the nanocellulose, this is the nanocellulose we have developed from insect fibers. The insect fiber is nothing but this one, the outer part. This outer part insect fiber is looks like it's not only leaf. This part, this part, and this part are like insect fiber. So that fiber is used to extract the cellulose, and the different methodology, ultrasonic methodology, as I told you, the novel extraction method and optimization has been done. And finally, we have identified that the cellulose and nanocellulose extracted is having some special character that can be used for food packaging material, and also different applicability for biodegradable products. So here, another important thing is also optimization of spraying process. That is the methodology process. That also can be used. So we worked under some particular methodology of film formation. So based on spraying methodology and based on the film formation. So that also we have studied and published here. And another important thing is while talking about insects and the cellulose, uh, this one is normally people know, but here I would like to just say you, Ethiopia is very famous for beer and beverages product. So the brewer-based waste is very highly available, and we have developed one project, and we completed such kind of cellulose extraction from the brewer waste, the sprint grain. So that also having high yield and high crystallinity nanocrystals we developed, and we pattern. We have some good products, and we published here based on that also. So this is some pictures which illustrates normally the cornstarch. Everywhere in world people are working edible film, and but here very specifically bulla. Bulla is local language, is nothing but N. This one. So this is known as bulla. People calling in local language bulla. So So we are having some projects, and also it's compared with the cornstarch. Corn is basically we are taken to as a control, then the bulla starch and everything. So you can see very good uh, 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 difference and color and everything. So still the research is going on related to such kind of starch because it's very peculiar to Ethiopia, and also lot of modification can be done and finding new novel products. So what we have done, I'm just sharing about this. And another important thing, interesting, is the pecking. So we have done some pecking extraction related to such kind of new product, but it's not new in Ethiopia. But in pectin related extraction, this particular fruit is very novel. It's having a high level of pectin yield, and also the pectin is going to be applicable for different food product functional food, but we have worked under extraction of pectin, optimization of pectin, and the cellulose especially undertaken extracted from NSET is reinforced, and we are developing and published here. It's having very special characteristics of food packaging materials, so it's published here. And this is another film. Bharat is nothing but it's a Amharic local language, so I just given here. After that, another important thing is want to just give you avocado. Avocado is having high level of starch. So here we have
Sandil Kumar sir,
assigned one particular seed project, and also the seed is extracted the starch
please mute
by
audio. Okay, please.
biocomposites by using starch extracted from avocado seed and some cellulose fortified property improvement that can be.
Excuse me, sir. Participant, kindly mute your audio. Mansi,
So
Participants, kindly mute your video and audio. If anybody is found switching on the video and audio, you will be removed from the meeting. Please. Miss Mansi. Miss Mansi.
Porkodi,
Miss
remove
Mansi.
Mansi. Porkodi, remove Mansi.
So
Please.
thank you. Here I want to just give you the new idea, novel thing. People may think about the starch extraction from avocado seeds. So we have lot of avocados, and also the seeds is normally discarded as a waste, but it have 40% of starch. So the people can think in this occasion would like to start work under the starch extraction from avocado seed that can be used for either fermentation for further products, and also the starch can be used for developing biodegradable material, biocomposite material, and all those things. But we had one project, we completed one peculiar property value added with respect to the cellulose fortified biocomposite film, which especially worked under for food packaging material. But this one, people may think about to increasing microbial activity or antioxidant activity to add extra extracts or functional material to think about to develop the novel product from avocado seed starch, because these are all very new and novel idea. So it's already published, and also now you can think about what kind of nano material or nano fibers can be fortified the biocomposite film with avocado seed starch, normally biodegradable food packaging material in terms of. So this is the food packaging material, and also edible films based on starch, based on pectin, based on protein also. So the people may think in this occasion to work towards this faculty development program can make all the way to think about the novel ideas. So another important thing, so we had a very interesting products, the natural color extractions. I don't know whether here this greens are available here in India. I don't know India or Tamil Nadu, but we have in Ethiopia normally until we identified that beta line extraction from this grains. Everywhere it's available. It is not a beetroot. It is not a beetroot. It's a normal grains. The people are daily using culinary purpose. They are utilizing that. But after we identified that beta line and extraction of color from this vegetable waste, It is also edible, but we have identified that the betaline extraction by using different novel things and extracted the betaline, that is natural product, and incorporating some AI methodologies, artificial neural network optimization, those things. It's commonly called GOSTA in Amharic language, in local language. It's very commonly available in everywhere, but here I don't know. So that's why I already told that these are all giving some new idea, novel idea. It's not unusual in Tamil Nadu. That's why. So people may think about here it's not still underutilized to think about how we can make some good natural product or natural related activities. So what we have done that's I want to just discuss with you here. So this one is first published here, identified that the color pigment extraction, and it can be applicable for anywhere. So this is published here, and based on this optimized process, it's comparatively very good yield of pigment has been done, this kind of waste product. So another important thing, as a food process, food development, I would like to discuss with you. We had identified some methodology processing based on planting. See, Ethiopia is very famous for wine also. So that we worked under one project. That particular project is concentrating about pre-processing for grape wine, for developing a new grapes plants. So in that point of view, 3309C is having very high property of producing wine, so that we are just working under plant biotechnology scientists to developing some additional chemical engineering processing, germination process and seeding process to sterilization process before plantation. So this modeling and optimization have done based on some modeling process, and laboratory test neural network has been done. Then particular grapes have developed about producing for particularly industry working for wine. This also very nice work we have done and developed for the patentable work. Another this thing, pharmaceutical. I don't want to leave the work we have done with respect to medicinal plants. This is one particular example. I am not. This is not time to discuss about the different traditional what medicinal plants in Ethiopia. One specific particular underutilized even in capital also. Some religious peoples are using that is known as gasho. Normally, people are calling gasho in local language. This particular underutilized but high effective in anti-nutritional, antimicrobial, and also medicinal value plant is undertaken for the cultural conditions, because in particular region only it's growing in Ethiopia. So it cannot be grown in different and widespread of regions, so that we have taken to work the cultural conditions to develop such kind of medicinal product in laboratory conditions. So in that laboratory conditions, how we can develop modeling and improve its callus formation and developing the product and everything is done in this project. So accordingly, we have developed this project, Gasho. It can be used, maybe can be export in future from Ethiopia to different world, because lot of medicinal exploitation can be done here. This is an idea even in Tamil Nadu or anywhere in villages or any tropical area or rural area. People may think to extract essential oil or plants, extract and everything. Even it cannot be grown in normal area. How it can be developed in laboratory conditions, like smart agriculture activity. In that point of view, we can use such kind of modeling and optimization process. So basically, this kind of attitude can be, people can think to work in future also. That I want to just give you what we have done in Ethiopia. So this is a very good idea for developing new medicinal product and all those things also. Uh, these are all ongoing projects. At present, people are working. Almost we have completed. This one I do like to just share with you here. Um, See here, this plant. It is available here in Tamil Nadu, but nobody knows about the potential of this particular plant. It is known as Tanadam. Normally, people are calling Tanadam. This Tanadam is known as local language. Tanadam is local language. In tropical area, in Kunnur, Ooty, in that particular tropical area, traditional medicine people are still using. After I came here, I'm just inquired about this plant. It is still in usage as a medicinal plant, but nobody knows about the exploitation how it can be used for the medicinal plants. But in Ethiopia, everywhere, if you go in coffee shop, without this plant, the people will not drink coffee. Coffee is without sugar, milk, such kind of coffee extract people are using, and they are just dipping this plant, and after extracting some phytochemicals, they are drinking. So there, there is some interesting background. Dena Adam. Adam, the first man, the person who are originated in world, he is known as Adam. Dena means hill. So the history behind the particular plant, name itself explaining that Dena Adam. Adam was using this plant for his health. That is the history behind this plant. So this plant normally still people are using for is traditional coffee or tea usage purpose. So why not we can think about to work under this plant? Normally, after I came here, I just went about that particular plant. Maybe the people who are seeing in Tamil Nadu here in this PPT can understand that it is known as Aruvada or Aruvadam. In Tamil, in this particular plant is called Aruvada or Aruvadam. Having lot of work also, it is having lot of medicinal value in Ethiopia, uh, uh, medicinal research, and also different kind of functional food, medicinal foods research activities are there. But still here in India, but still here in Tamil Nadu, nobody are not concentrating on that one. But some people in traditionally in tropical regions are using this plant, this one. This is rosemary. Rosemary also they are using. This is also this Kannadam. It's known as ruta. So as I told you, rosemary is also the commonly available in Ethiopia. Each and every house the people are having. It's having high antioxidant and antimicrobial property. Essential oil is very high functional activities. They can be used here. It also can be used for developing different essential oils, and not only essential oils. That essential oil can be applicable for in what region. So may researcher or attending this FDP can think about emulsion form, the nano emulsion form, and also nano encapsulation form. And the new things can be developed from essential oil, can be used for the further research activities. And these are all some advantages of using rosemary oil, essential oil. So there is no need of any explanation to say about the essential oil for rosemary, everything. So after that, pectin, as I told you, the pectin is extracted from bellows, that is the prickly pear, already I told you, no. But now the pectin extracted from waste. Normally, researchers, additional values can be done, which can be extracted from waste. And what can be extracted from waste? That only will give the researchers additional value. So that the pectin is extracted from coffee waste. But here I would like to just this with you, coffee is the traditional culture. Everywhere, anywhere the coffee is available and plant is available, so waste is also available. So this is high level of coffee waste, that is after peeling. The peel can be taken like this, very huge amount of tons and tons of coffee waste are normally available in Ethiopia. So we identified that the pectin is available in that one, and we are now working under extracting pectin from the coffee processing waste. After coffee processing waste, the only thing we identified the pectin is not uh, uh, pectin is not in good color. That is only disadvantages here. We identified that it looks like some brown color. So that the thing is can be people maybe work under extraction from coffee waste, coffee process has and also. So until now, I just discussed about what I have done and what we have done in Ethiopia, and also last 1 hour I discussed about everything what we have done, and also the opportunity given to this FDP program, maybe doctorates, and also people thinking to work new area, new idea for PhDs and research may have give some trigger values to work under research. Thank you so much for given opportunities, and thank you so much.
It's time for query session. Dear participants, is there any queries?
The essential oil or the plant extract, how is it mixed with the conventional food products, say, as you said, meat?
Sir, please, can you?
How the plant extract, say, essential oil is mixed with other conventional food products, say, meat?
Sir, meat. Meat products are actually still some researches is going on, sir. Related to mix with it's not directly essential oil and extract cannot be applicable. It can be applied or applicable with encapsulation or micro encapsulation or nano encapsulation, like that we can apply, sir. In that point of view, you can think about to develop a formulation, and that formulation some optimization needs. So based on that, you have to develop a emulsion or coating related formulation, then you can apply as a coating for meat.
Is there any possibility to have a new product to grow in plant which will be mixed up of conventional fruit and conventional other protein products, say meat, and to grow that newly developed fruit in a plant which will contain the qualities of the conventional fruit and the conventional meat? It's like a genetically altered product.
Yes, sir. It depends upon what type of work you have taken, what you are going to concentrate related work, sir. It needs preliminary test and preliminary research to test about even product or fruit or anything, whether you are working for the coating product or spraying product or any packing material and everything. It's differ with respect to property of both product and also coating or emulsion or anything. It's related to different chemical engineering properties, water vapor permeabilities, and thermal properties, and also additional uh, diffusion properties also. So it depends upon what kind of material, base material or polymeric material you are going to use, which extract or anything. It's related to pathogen protection activity or only nutritional protection activity or any environmental protection activity. So we have to work and we have to go through some preliminary testing materials. Even such kind of coating material, the formulation can be used polymeric material based on pectin or polymeric starch or anything. So it depends upon the work and depends upon the products.
Okay, thank you.
Participant can raise your question or put it in chat box.
Thank you so much, sir, for your informative presentation. Let's wind up the session.
Thank you. Thank you so much.